The overall goal of this procedure is to assemble a bench-scale photosynthetic bioreactor with continuous light, pH, and temperature monitoring for algal growth experiments.
So quantifying algal growth using a monitored and controlled setup allows researchers to better assess algal growth, which can help answer key questions in making algal-based biofuels a reality.
The main advantage of this approach is that it is a customizable and potentially more affordable setup for monitoring algal growth experiments in real time.
We wanted to develop this type of photosynthetic bioreactor when we realized the importance of maintaining control within the algae's dynamic culturing environment.
Visual demonstration of this method is critical, as many of the steps are difficult to learn if you are not familiar with electrical engineering terminology and practices.
To begin this procedure, construct a bench-scale PBR. Determine the size, shape, and design of the PBR body and lid, as described in the text protocol. Using the transmitter wire, connect the unity gain amplifier to the pH probe. Then, pick up the coaxial adapter that has positive and negative port terminals. Connect the adapter to the other end of the unity gain amplifier. To make a low-pass filter, use wire strippers to cut two 15cm pieces of green connector wire and one 30cm piece of black connector wire. Strip approximately 0.6 cm of insulation from one end of each of the green wires and from both ends of the black wire. Next, strip approximately 1.25 cm from the other end of the green wires. Carefully wrap one leg of the 1,000